what we're going to talk about today is slope, something that you discuss in Algebra 1 and a topic that you discuss in geometry as well. And when we were talking about it in Algebra 2, slope describes how steep a line is. Sometimes I say slanted, and it's the greater the absolute value of the slope, the steeper the line. But more importantly here, as we look at the examples, you read slope from left to right. So if we look at example 1, hopefully what you're thinking based on the last unit is that this red line here is going up and up and up and up. It's just going up a little bit, so it's an increasing slope. And when it's going upward, that means that our slope is said to be positive. And it's fairly intuitive. If we look at example 2, our graph is going down and down and down and down. And downward, a decreasing line in this case will have a slope that's negative. And in most cases, people tend to have no trouble with the positive and the negative. It's the third and the fourth examples that cause a little bit of trouble. But what we see in the third example is we see a horizontal line. And what I said in the notes here is it's like walking across the floor. But the slope of a horizontal line is you're not going up, you're not going down, so the slope of a horizontal line is 0. And what I sometimes say is that you're moving forward. And finally, vertical line, you can't walk across that line. You can walk uphill, like in example 1, or you can walk downhill in example 2, and you can walk forward in example 3. But you can't walk up or down the vertical line. And when we have that, the slope then for a vertical line is undefined. Again, hopefully this is familiar to you. As I flip here, keep in mind, a vertical line is not a function. It fails the vertical line test. Maybe that'll be something that can be helpful to you when you try to remember that the slope of a vertical line is undefined. And just a reminder as well, for functions, there is exactly one x assigned to each y, which ultimately then means that no x's can repeat for something to be a function. And that was from the last unit. But probably what you really care about is, what's that formula again? And I've got something a little bit wrong on this page, but we can fix it. M is the abbreviation for slope. René Descartes, a French mathematician, discovered slope. If you go to the French-English dictionary and you look up the word slope, guess what letter it starts with in the French dictionary? It starts with M. That's where it came from. It's defined as rise over run. And then here, the slope formula is actually delta y over delta x. That triangle means delta, Greek letter. It means the change in y over the change in x. And I have a mistake on your paper that you probably can just pencil over real quick. But luckily, I don't have a mistake on the formula. And the formula to calculate slope is y2 minus y1 over x2 minus x1. Some teachers teach it as y1 minus y2 over x1 minus x2, and that is fine as well. It just depends on who your Algebra 1 and your geometry teachers were. I tend to use the one that's typed, but feel free to use whatever your Algebra 1 or geometry teacher taught you. So when we look at these examples here, let's label x1 and y1, x2 and y2. And luckily you can see right there on your paper what the formula for slope is, and we fill it in. It is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That equals our slope. And then we calculate that out. Well, 2 minus 3 is negative 1. 4 minus 2 is 2. And there's our slope. Same idea. Problem number 2. If we label these, here's x1 and here's y1, x2 and y2, and we put it back in the formula. But the formula is something that you need to sit down and conceivably memorize if you don't have it memorized already. But once you know it, y2 minus y1 over x2 minus x1 equals our slope. Slope abbreviated as m. Then we do that calculation. Negative 3 minus 4 is negative 7. Negative 1 minus 3 is negative 4. And don't leave it as negative 7 divided by negative 4. Negative divided by negative is positive. So we really do want the 7/4. Example 3. Fractions in here, but it's not as bad as it may seem. When we look at this particular problem here, it's still going to start with label. x1, y1, x2, and y2. And we fill in the formula. y2 minus y1 divided by x2 minus x1. That equals our slope, but I want to put my answer here right there, so I'll do this. So slope equals 1/6 minus 1/6 is 0. Negative 3/4 minus 1/3. Well, we can type that in our calculator. Remember, alpha y equals will give us the fraction button, and it's negative 3/4 minus, and then alpha y equals, enter, gives us, then we can put in the 1/3, and that gives us negative 13/12. By the way, if you have an out-of-date calculator, you can still do this. Negative 3 divided by 4 minus 1 divided by 3. You get this big long decimal. Then you can hit math, enter, enter, and it will convert it. It will write this as negative 13 divided by 12 in your calculator. But your out-of-date calculator can still do this computation, if you're wondering. But ultimately here, what we need to know is, what does 0 divided by negative 13/12 equal? And what it equals is 0. If you don't know that, I'm not taking the calculator out of your hand, so type it in. It's 0 divided by negative 13/12. And I didn't use my fraction button, but it's not going to make any difference because there it equals 0. And consequently, what we know about this, even though the problem's not asking that, is that this is a horizontal line. And you don't need that. But what if you're asked it sometime? The slope of a horizontal line is 0. The slope of a vertical line is undefined. Problem number 4. Same idea. And what we need is to label, and then we fill it in the formula. Here's x1, here's y1, here's x2 and y2. We fill it in. y2 minus y1 over x2 minus x1 equals our slope. And 0 minus 4 is negative 4. 2 minus 2 is 0. And when 0 is underneath, the function is undefined. So that's a little technique that I have that I like to say. When 0 is underneath, the fraction is undefined. That's a technique that works for me. It may or may not work for you. If you're not sure, again, take out your calculator. Negative 4 divided by 0. And when we divide it, we get an error statement. And when we get this error statement, that can be a hint that it's undefined. So lastly, as we flip our paper over, now that we've seen slope again, what we know on this one, even though it didn't print very well, it's 1/3 here for our slope, is what if we already know the slope and we want to find the value of the point? And I want to solve this one algebraically, so I'm going to continue to start with x1, y1, x2, and y2. And we're going to fill in the formula. Well, it's r minus 4 divided by negative 5 minus 1 equals our slope. But this time, instead of writing m, we're going to write down what it equals, which is the 1/3. And we can simplify this a little bit. So this becomes r minus 4 over negative 6 equals 1/3. And to solve this, we're going to cross multiply. This times this times this. Proportion. Thinking back to 6th grade, 7th grade math a little bit. So we multiply 3 times r minus 4 equals negative 6 times 1. It does not matter if you put negative 6 times 1 over there on the left side and 3 times r minus 4 on the right side. It doesn't make any difference. I'm going to distribute. So we have 3r minus 12 equals negative 6. And we'll finish by solving our equation. Add 12, both sides. And we end up with 3r equals 6. And finally, divide both sides by 3. R equals 2. A little bit more algebra 2, or at least to the geometry level, from the front page, which is definitely algebra 1. Looking at our last problem, again, we want to find a value in here. If this is unreadable, the slope should be negative 5 on problem number 6. And let's label the points. Here's x1, here's y1, x2, y2. Again, our slope is -5, and we fill this in. So it's -4 minus 6 divided by r minus -2 equals our slope, which is -5. And what we need to do, first of all, is we need to figure out, well, -4 minus 6 is -10. Simplify this a little bit. R minus a -2, well, a double negative is going to give us a positive, which means down here in the bottom of our fraction, we're going to get R plus 2, -5. The thing that some people forget about on this problem is that we can rewrite -5 as -5/1. Because again, what we want to do, figure out what the value of r is we want to multiply. So we have -10 times 1 equals -5 times r plus 2. And then we're going to use our equation solving skills. -10 times 1 is -10. And then over here we distribute -5r minus 10. Make sure you got the correct sign. And when we finish, or get close to finishing, we're going to add 10 to both sides. So we have 0 equals -5r. And when we undo the multiplication here by dividing, we end up with r equals 0. At the bottom of your notes, I have just a little summary there that you can read. We've already talked about that. But I do want to finish by looking at one problem on your practice here. We'll just look at problem number 1 because we didn't have an example of this in there. But it says, tell whether the slope of the line is positive, negative, 0, or undefined. Then find the slope if it exists. And I think that most people are pretty competent with figuring out the fact that the slope of this line on number 1, coming from the left, we're going up, 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 which means that it's positive. But just as a reminder, what we do to figure out the slope here, because slope is defined as rise over run, is we find a couple points that are right on the corner. For instance, I picked this point here, 0, -2, and I also picked this point way up here at 2, 5. And we can draw a triangle. Again, slope is rise over run. So when we want to find the slope of this line, it's 1, 2, 3, 4, 5, 6, 7. I counted the boxes. 7. There's the rise. Run. 1, 2. So hopefully that'll get you started on the practice. The rest of it, I hope, will be straightforward. Again, video on slope